Welcome back to Summarize Science, where we break down complex research for everyone to understand. Today, we are looking at a fascinating study about how large language models, or LLMs, solve problems. Specifically, researchers wanted to know if AI can find the shortest path between 2 points on a map. This sounds simple, but it is a perfect test to see if an AI is actually reasoning or just memorizing patterns. The study focused on 2 main challenges for the AI: spatial transfer and length scaling. Spatial transfer is the ability to solve a path on a map the AI has never seen before. Length scaling is the ability to find paths that are longer than any of the examples it saw during its training. The researchers discovered that these AI models are actually quite good at learning the rules of a map. They can easily find their way around completely new layouts, which shows a level of systematic generalization. However, everything falls apart when the path gets too long. Even if an AI can solve small pieces of a journey, it struggles to stitch them together into one long trip. They call this recursive instability, meaning the AI becomes more likely to make a mistake as it generates more steps. This is a big deal because it shows that modern AI has a hard limit on how far it can plan ahead. The study also looked at what kind of data helps the AI learn best. Interestingly, they found that it is better to give the AI many different questions rather than many different answers to the same question. If you have a limited training budget, you should focus on covering as many unique scenarios as possible. They also explored the difference between coverage and diversity in training. Coverage refers to how many unique map locations the AI has seen, which seems to set the overall limit for its performance. Diversity is how those locations are combined, which helps the AI reach that performance limit faster. One surprising finding was that adding just a few examples of slightly longer paths can significantly help the model. However, adding paths that are much longer than the target actually makes the model perform worse. The researchers then tested reinforcement learning, a popular method for improving AI. They found that while this method makes the training more stable, it doesn't actually help the AI break through its original limits. It turns out that supervised fine-tuning is often more efficient if you have high-quality data. Even giving the AI more thinking time during its response doesn't solve the long path failure. It might improve performance slightly, but the core issue of scaling to long distances remains. To recap, AI is great at applying rules to new situations, but struggles with long, complex sequences. This tells us that simply making models bigger or training them longer might not be enough to solve deep reasoning problems. In the future, we may need new ways to help AI maintain stability over long-horizon tasks. This research provides a roadmap for building better datasets and more reliable planning tools. Understanding these specific failures is the first step toward creating AI that can truly navigate our complex world.